Hey everybody, and welcome to episode 257 of the JavaScript Jabber Show. This week on our panel we have Amy Knight.
Hello.
AJ O'Neill.
Yo, coming at you live from jet-lag Pleasant Grove.
I'm Charles Max Wood from devchat.tv. May want to go check out React Remote Conf or Angular Remote Conf coming up, and you can submit talks. We have a special guest this week, and that's Johannes Schickling. Did I say that right?
That's correct. Hi, everybody.
Do you want to give us a brief introduction, who you are, what you do?
Sure. I'm Johannes. I'm currently living in Berlin, and I'm the founder of Graphcool. Before that, I founded a different company, which was called Optonaut. It was like an Instagram for VR, but we sold that company roughly a year ago. And since then, we're working on Graphcool.
Very nice. Now, this was a referral that we got from Uri Goldstein, who we had on a while back, and talked to him about GraphQL. Now, Graphcool is a backend as a service for GraphQL?
Exactly, yeah.
Do you want to just give us a brief recap of what GraphQL is? We won't spend too much time. People can go listen to the episode we did with Uri, but I think it'll help kind of set the stage for what we're talking about today.
Sure. So I think what most developers are familiar with.
This episode is sponsored by Front-End Masters. Engineers have watched over 2 million hours of Front-End Masters videos to upgrade their skills in the latest best practices in front-end development and Node.js. Popular video courses of theirs include courses on Advanced JavaScript, Angular 2, React, API design with Node, and functional and asynchronous JavaScript. Many of their teachers have even been guests on JavaScript Jabber. Check them out at frontendmasters.com. With Uri, but I think it'll help kind of set the stage for what we're talking about today.
Sure. So I think what most developers are familiar with are REST APIs. GraphQL, you can think about GraphQL in many ways as a successor to REST APIs. So it solves one of basically most of the problems of REST APIs. So for example, how do you structure your API in a way? Do you have structured endpoints like a deeply nested way, or are they completely flat? You can selectively say what kind of data you want. So imagine that if you do a request to REST API, you get JSON back. And what you do with a GraphQL API, you kind of send just the structure of the JSON, so just the keys to the server and just the keys you want. And the GraphQL server kind of fills that out for you and sends you back data of in the shape of the structure exactly you specify based on a request. So you can kind of use it as a drop-in replacement for REST APIs, and that opens up a whole new world for different kind of applications, and is in general just a better replacement. It has many benefits. For example, it's in general more performance, since you just use way less of your data bandwidth, since you just query the data you need. And you can also save a lot of round trips, since you can get nested data you wouldn't be able to get before. So the best way to kind of understand about all of that is just try out GraphQL. And yeah, that's fantastic.
Yeah, I really like it as kind of it reminds me a bit of it is QL stands for query language, but it reminds me a little bit of SQL, except it's JSON structures, and yeah, you get back a really clean representation of your data, which
exactly.
Works really nicely, yeah. And you don't have to set up because this was the thing that always drove me nuts about REST, was that I had to set up an endpoint for each set of data I wanted to get back. And so even if I was requesting the same data, if I wanted it structured a little bit differently, I either had to send back more information than I needed so I could hit the endpoint for multiple uses, or I had to create endpoints for each different representation of the data I wanted.
Exactly. And then you just have this mess on the back end where you cannot really maintain it anymore, since you have either a lot of duplicated endpoints or just a few fat endpoints that give you way more than you actually need in most cases, which makes it slow and horrible for mobile devices.
Right. So how do you go from GraphQL to having a backend as a service? Because it seems like then I'd still have to go through the trouble of like specifying what my data is and telling you how to store it, right?
Kind of. So you can kind of like, if you're already familiar with a mental model around parse, or maybe you've used Firebase, then you're already familiar with these concepts. And GraphQL just make that so much easier. So there are a lot of nice benefits of using GraphQL instead of proprietary technology. So, for example, Parse and Firebase, they require you to use SDKs to make it really work. With Graphcool, you can you can really just use GraphQL as a transport layer. Then basically the way you specify what kind of data you want to store, you can do that in a couple of ways. One way might be to just visually create a set of models where you basically just say, I have a model called a tweet, and a tweet has a text, it has a created at, which is a date, and so on. The other way would be to specify it in what's called the GraphQL IDL. So that stands for Interface Definition Language. And there you can basically just write out all of your type definitions and then sync that with our product. So this is like the most concise way how you can actually define your data schema for your backend.
So I want to ask a question. I don't recall us talking about this in too much depth before, but I was watching something I think you did this morning to prep for today, and you're kind of talking about like rewriting versus a greenfield app and implementing GraphQL. So I'm kind of curious your thoughts on like if you wanted to start using this, but you don't have the luxury of working on a brand new project, like what your recommended approach would be there, and like what success stories you've seen. I know it sounds like GitHub potentially rewrote. I don't think they started from scratch. I could be wrong. But if you can go into that, I'd be really curious.
Definitely. Do you mean about GraphCool or GraphQL in general?
Just GraphQL in general, because I think what I was watching this morning, they recommended like starting on the front end first and just going like component by component. So if you could maybe talk about that a little bit, I think it would be really interesting for a lot of people.
Right. That's a super nice question. So GraphQL basically started out this way. So GraphQL was developed at Facebook. So I think it's now 5 years old. And the way it started out was really by wrapping existing services in a unifying way that front-end developers and client developers have like just a single unified way of accessing data and mutating data. So what they in fact did is they had like their huge universe of different services and just put basically a GraphQL proxy in front of them, so that you have one single endpoint you talk to, and this proxy kind of translates it to the old way. So maybe that might be a REST API, maybe that's an XML API, maybe some kind of RPC style API, and it really acted as a proxy layer. And this is a really feasible approach for people to introduce GraphQL in their current projects. So GraphQL is in fact kind of made for migrating your existing system to use GraphQL.
Okay, and then one other thing that what I was watching this morning that they mentioned was that it was definitely easier, I guess, to go with Apollo, since you can, from my understanding, you're not just tied to React. But are there other reasons why you would want to go with that versus Relay?
Okay, so you're asking about Relay versus Apollo. That's quite interesting.
Well, and specifically, because I know we've talked about this before, but specifically, if you wanted to like rewrite something.
Right. So in general, if you say rewriting, do you mean the backend or the front end?
The front end.
Right. So basically, it depends on what your scenario looks like. I don't think that there is a good answer to whether you should choose Apollo or Relay. It really depends on your situation, your use case. So if your use case fits Relay, and there is unfortunately no really easy way to say whether it fits or not. You just need a bit of experience with that. But then Relay makes you incredibly fast and gives you a lot of nice guarantees around using the system. So the way I always try to explain it to people is what React kind of does for your rendering, so that you just declare, this is how my component should look like, and you don't have to worry about that the DOM is manipulated in a certain way. Relay gives you the same kind of guarantees for your data. On the downside, the cases where this works, these are pretty limited. So for some scenarios, it might work really well. For other scenarios, you might find yourself pretty limited. And in these scenarios, Apollo is a better fit, since it gives you a lot of flexibility and just the freedom to do things in a certain way how you want it to be. So it's really just a spectrum of flexibility and magic, I would say.
So talking about GraphQL in general, what's it like building a backend for it? I mean, we talked a little bit about, some of your approaches to creating your data models and things like that, but I'm assuming, is this built in JavaScript? It looks like it backs up onto AWS Lambda. So how does that all hold together so that it actually will work for me if I want to store data in a GraphQL compatible backend?
Right. So again, do you refer to a person in general building a GraphQL backend, or a person who wants to use our service?
Why don't we start with your service, and then we can get into what it takes to build a backend for GraphQL, if you determine that backend as a service isn't the way you want to go.
Right. So in general, the way you start out is really just by specifying your data structure, so your data schema. And just by specifying that, we generate a whole set of APIs for you. So basically all CRUD style operations you get out of the box. So maybe if we go back to this Twitter example, and you have like a tweet has a text and so on, and there's also a user, and a tweet has an author and so on. We generate basically a set of APIs for you that you can query all tweets or a specific tweet, and these are just all entry points into your data graph, and from there you can traverse the graph via your defined relations. Then there are all these mutations. So for example, that you get mutations to create a tweet, to update a tweet, or to delete a tweet. So these are just your building blocks, how you can store and manipulate data. And this is basically everything you need from a client perspective to query or mutate data. Does it somewhat answer your question regarding Graphcool?
Yeah, it does. So where are the examples where I may not want to use a backend as a service? Because it seems like you cover the basics, so I'm kind of trying to feel out where are the edges of this particular use case.
Right. That's a really good point. That was kind of also our motivation to start with Graphcool in the first place, since I've used services like Parse or Firebase before, and I got pretty frustrated because it's not really flexible and also not extendable, so that you can just really get to these basic CRUD style operations, but you cannot really go beyond. You cannot. You don't have an expressive way to define your data structure and to implement some kind of business logic. And this is where we are taking a different approach, that we combine GraphQL with serverless functions and providers like AWS Lambda, that you have this set, this base set of APIs, and you can extend it in any other way you might want to with serverless functions. So if you need a special mutation, you can just implement it yourself and add it to your schema. And this is basically how we are pushing the limit versus where you might want to implement your own backend, but you really don't need it anymore, since the things we don't provide for you out of the box, you can just tag into that.
So I'm thinking about CouchDB and about REST. So one of the benefits, it sounds like, to GraphQL is that you can specify a query and then you can get back the data that's based on that query. But in most cases, you have a query that has, like, you're going to do the same query over and over and over again. And so you're going to have some sort of structure. And on the one end, it seems like REST does a really good job at that, because you can implement an endpoint that gives you exactly the data that you need that's optimized for that structure. And then something like CouchDB also, as the data comes in, it's organized into the appropriate structure. So the retrieval time and processing time on that is like 0. So what is the advantage of and the use cases of GraphQL as opposed to those two scenarios?
Right. So that also kind of relates to a question we're also getting quite often when people ask us, how do we implement caching, or how do you implement caching in general with GraphQL? So you definitely have to think a bit differently how you might have implemented it on for normal REST APIs. But you can basically cache GraphQL APIs in a whole new way and make it really, really efficient, actually. Since you're caching, basically, you're thinking about your data in terms of a data graph, and you can cache on many different levels there and make it really efficient to let people access your data. So what we, for example, do is we analyze what are the queries people mostly fire. So if we see like these are like the top 5 really advanced queries, which take quite a lot of time for us to execute the query, then over time we're adapting our indices around that to make these queries faster. And we also implement a whole hierarchy of different cachings to that, since we are aware of which kind of data changes. So we can store a lot of data in Redis, which makes it really fast to retrieve.
So is there a particular use case that you see where having the ability to create extremely dynamic queries without necessarily the benefit of the caching is a big win for people?
Could you give me an example for that?
Well, that's what I'm asking for. So it's with GraphQL, because it's a graph, making the query each time rather than specifying an endpoint, you can be very dynamic in how you want to query something. Because you're not necessarily. I mean, I would assume that there's a use case where you're not querying the same structure over and over again, and that's what makes the graph have great appeal. And maybe it's just that you can service such a wide variety of customers, and then you're saying the caching is what helps you to optimize for specific customers.
Right. So I think we have to look at this from 2 different angles. So one is, how do you implement all of that, and how do you make it fast? I think this is something what we, for example, give you out of the box. And if you're building your own GraphQL backend, then this is where you have to get to pull up some smart tricks. Then from a client perspective, And when you're developing it from your client, from a front-end developer perspective, then you have to think about what kind of data am I expecting, and you write the query to specify exactly what kind of structure you want. And if you don't want to send that all the time over the wire, then you can also use like a technique what Facebook internally uses, what are called persisted queries. So what you basically do is you don't send the entire query, but you just basically send a hash of that, or some kind of pointer to that query, and the query is stored internally on the server. So that kind of gives you the same characteristics around a REST API in terms of that.
So the query. Go ahead.
So you basically have one kind of endpoint where you send, I want this data, and you get that back without needing to specify it on every request. But at development time, you still have the same nice guarantees around GraphQL.
So it sounds like you get the best of both worlds, in that essentially your query is more or less a schema. And so when you're in development, you're sending the schema of the data you want back every time. And when you're in production, you're saving the schema as a REST endpoint so that you can retrieve it quickly and have the caching benefits and such.
It's a sub tree of the schema, of the entire schema. Yes, this is what a query really is.
Yeah, but you said that you can create a hash of that, and then it
this is an implementation detail of your backend, how you really do it. So it's basically a key value store of, this is my key, how I want to let the client tell me what kind of query I should give back. And you basically just store this key value store of keys and the queries.
Gotcha. So one other thing I'm wondering about is security. We talked a bit about GraphQL with Uri, but I don't know if we dug into the security of the query. So how do you make sure that, maybe there's this hacker out there named Amy Knight, and she's trying to get at some of my data, and or I only want her to access some of my data, but not all of the data, right? I don't want her getting social security numbers or something.
Right, that's a really good question. Trust me
with your social security number, Chuck.
So that's a really good question. Also, one of the things what we wanted to do differently compared to existing services. So with existing services, you can usually use fairly simple and basic ACL rules. Mm-hmm. What we basically we leverage the entire data graph to let you specify security and permission rules. So you can really easily specify something like this, that let's say we're building Twitter, and for Twitter, one user is trying to follow the other one, but the other one has first to accept the follow request, and just when this has been accepted, then user A can read user B's tweets, something like this. Or like really complex rules which go over many relations. So you can do that by just specifying basically GraphQL queries to express your permission logic and your relational rules. And you can specify if these kind of conditions are met, then allow or deny the certain action. So whether somebody should be able to read something or update something and so on. And if that isn't enough, then you can also, for every kind of operation, specify a set of Lambda functions, which evaluate and based on the result, whether it's true or false, or the permission rule gets allowed or denied.
So how do you authenticate somebody against GraphQL in the first place? Right. Do you just send a query?
Right, that's a good question. Right. So we just talked about authorization. Authentication is an entirely decoupled step of that. So for GraphCool, we basically allow a really flexible set of what we call authentication providers. So you could use services like Auth0, Twitter login, Facebook login. You could use digits or use a simple email password-based built-in authentication provider. Or you could also simply implement your own one. If you, for example, if you don't a greenfield project, but you have an existing customer base that you want to enable existing users to authenticate without changing their password, for example. So, and going back to your question on a GraphQL level, how that works. Currently, we're just expecting a JWT sent as an HTTP header with every request. So that's how it works for queries and mutations. And for subscriptions, it's basically a property you specify on the connection.
That makes sense. And then on the back end, it has some way of verifying the JWT and finding out who you are and what permissions you should have.
Exactly. So if you're, for example...
All right, let's take a break and earn a little money for the show by talking about Hired.com. Hired is the world's most intelligent talent matching platform for full-time and contract opportunities in engineering, development, design, product management, data science, sales, and marketing. They put you in control, fill out an application, and then top employers apply to hire you. Throughout the process, your dedicated talent advocate will also have your back, providing unbiased career coaching to help you put your best foot forward with potential employers. And Hired offers access to more than 4,000 innovative employers, including big brand names like Facebook and smaller emerging startups. The size and type of company you want to connect with is totally up to you. And they help people find new opportunities in 17 major cities in North America, Europe, Asia, and Australia. So if you're open to relocation, you can let them know and they'll work that in too. Finally, if you use our link, you can earn double the normal hiring bonus. The normal hiring bonus is $1,000 and they give you $2,000 instead. So go check them out at hired.com/JavaScriptJabber.
Exactly. So if you're, for example, using Auth0, then we're directly reusing your Auth0 token. You, by setting up your account, you basically just share the Auth0 secret with us that we can verify your tokens on your behalf. And for other providers, we basically swap out, for example, a temporary Facebook authentication token with a session token from our system, and then we can verify whether your session is valid or not.
So one other thing that I've been seeing a lot of, and it seems like a lot of these backend as a service kind of lend themselves to this, and I've had conversations with a few other people. I think we're going to have Travis Tidwell on from Form.io here in a few weeks, and we had him on Adventures in Angular. And anyway, one of the things that we talked about there were serverless apps. And, you know, the term kind of to me means I'm not the one managing the server, as opposed to there's no back end to it. Is this a paradigm that you've been talking to people about, or am I misunderstanding the paradigm some?
Right. So the term serverless means a lot of things, and it is kind of misleading in a way that it means so many things. But the good thing is our service encapsulates all of them. So this is why we are using them to coin our service. So what you just said is that serverless kind of describes a level of abstraction. So if you think about hardware versus you have EC2 instances versus you have maybe a managed Redis database on AWS versus you have something like S3, these are all different levels of abstraction. So if you have your own hardware server somewhere in your basement, that's like the lowest level of abstraction. Then the next one is like a virtual server. Then the next one might be like what Redis or RDS and all of these services are. You still have to think about somewhat how much performance do I want to have on an average and on a maximum. And with services like S3, for example, or AWS Lambda, you don't have to think at all about the capacity anymore, because you just pay as you go. And this is really what serverless means on that level.
Can I like back up and actually ask a question? Because AWS Lambda is something that I first heard about like recently. So can we talk about very briefly what that is? I know we've kind of touched on this a little bit in the past couple of weeks on other episodes when we were talking to the Microsoft people, but.
Sure. So AWS Lambda is kind of when you deploy your own server, for example, with Heroku or something like this, then you basically build your entire backend application, and it has mostly like a framework, and you just spin it up, and it usually has like an HTTP server running and so on. And then you can just serve a lot of requests, and one server manages a lot of requests. What AWS Lambda does is you just implement basically a function, and this function is executed when something happens. So when something happens could mean as an HTTP request comes in, then the request is basically taken, put into the function is executed, and can return something. So you basically get a function so if you think about it in a middleware concept, then your function is basically the implementing function. Other events could be, if you want to use it for a worker queue, then your AWS Lambda function could be called for every new event coming through your queue, or you can have it run as a cron job and so on. So you basically you break all of your server down into the smallest pieces, which are functions, and these functions are executed for you on your behalf with services like AWS Lambda.
Could you maybe give an example, like a specific example? Because I think that will really help people who are not familiar with this, of like what you would use that for, like an actual specific example.
Right. So imagine you have a queue, and into this queue, every time a new user signs up, there's like a message put into this queue. And every time a message comes in, you execute your function. And this function, for example, is just responsible for sending this user a welcome email. Perfect. So you can really break down your business logic into small chunks of logic. And all of these functions do one particular thing.
Right. So if you have some job that needs to happen on a regular basis, or you need, one thing that I've looked at doing with something like AWS Lambda is I have a Slack channel for some of the products that I have out there, or some of the conferences I'm putting on. And so when I keep thinking, it'd be nice to hit a webhook on Zapier and then have it hit a Lambda function, and all the Lambda function does is add somebody to the Slack room.
For example.
Sounds really cool.
Yeah, and so
if you think about it,
you just make the request and it does the one thing. And so it can be a side effect, it can be something else. But yeah.
Exactly. And now you're talking about side effects, and then we can talk about really functional programming, that you can either you implement your functions in a pure way that they map data, which you can also use Lambda for, mm-hmm. or that they perform side effects like send an email, sending some kind of text notification, or performing a side effect. And if you think about it, that an HTTP request which is being answered, this is also just a function which is invoked, and AWS Lambda kind of abstracts your HTTP server away. So in your application stack, you don't have to worry anymore, how do I implement HTTP? But AWS Lambda just invokes your function when an HTTP request comes in. You can just worry about the response you want to send back. And this is all what your function does, and you don't have to worry about scaling. I think this is one of the biggest benefits of serverless architectures, is that you don't have to worry about scaling.
Yeah, and when we talk about microservices, which are usually just very small apps that do a specific thing, this is kind of the very bottom end of that where it's one function. It does one thing. And so you can set up several functions across Lambda, and then you just hit the function that represents the thing that you want done.
Yeah. Essentially, every Lambda function is kind of a microservice. But in a traditional way, usually you deploy your microservices kind of in a Docker cluster, or you usually host them yourself, and you have to worry about provisioning. Versus with a serverless approach, you, for example, if you don't get any load over a month, then you basically pay nothing. And if you suddenly get a traffic spike and you get like millions of requests, then you don't need to provision thousands of servers. But AWS basically builds you on a millisecond basis. It's also just not AWS doing that. There, you can also use like Google Cloud Functions, IBM Bluemix, Azure. There are like a lot of different providers for serverless functions.
Yep.
But going back to your previous question, actually, so this is one thing what serverless means. The other thing what serverless means is kind of synonymous now with these functions as a service. So when we previously talked about S3, is basically serverless service that you don't need to worry about scaling. But there is also this other company called Serverless, which directly took this term and brand themselves on it. And they just make it really, really easy for you to specify these functions and deploy these functions. And in fact, we are directly integrating with their infrastructure or with their tooling, that people can specify their functions in a way they like, and deploy it with serverless, and it's directly integrated with our system.
So how does somebody go about testing things with Graphcool?
Right. So testing, do you refer to business logic? Do you refer to integration tests that you say, like, this is my entire system and I want to test like the entire flow of 10 users signing up and they get emails and so on. So on what kind of level of tests are you talking about?
I'm thinking more along the lines of the integration tests. Most unit tests and business logic tests are pretty straightforward, I think.
Right, exactly. So for business logic, just to recap, you can basically use existing testing frameworks to test your functions. So all of that can happen in a pure unit test way. So integration tests, we are trying to make this really easy. So you have maybe your existing project in production or in staging or in development. What you can do is just take an existing project with their entire database and so on, and basically clone this entire project. As part of your CI process, basically run your tests against it, make sure that everything happens as it should be, and then you tear it down again.
Yep. So one other thing that I want to ask about really quickly is just, and this goes back to our conversation about backend as a service and microservices and things like that. Do you see web applications going more and more this way as time goes on, or do you think just a certain subclass of web applications are going to adopt things like Graphcool or Firebase or whatever, and just not build a backend system that's customized?
Right. So in general, I think it's moving more and more towards that direction. So it's basically all about a level of abstraction. So what we really believe in is that going forward, software is more and more built by combining existing services. So you might use something like Algolia to give you a really fast and instant search. You might use something like Auth0 to handle your authentication. And so by that, you're really composing your application stack with different services. And where we kind of fit into that is basically giving you a really nice event-driven GraphQL database, if you want to think about it this way. and that works with your existing tools. And it just is a better replacement for MongoDB or a Postgres.
So really quickly, I just have a couple more things that you told us about before the show that I just want to bring up. One of them is that you're kind of toward the top of Hacker News.
Yeah.
So I'm curious, what do you think that indicates about the way that things are going? You know, just as we kind of talked about here.
Right. So we're currently on the Hacker News front page with a new tool we've built, which is called GraphQL Up. So GraphQL Up basically solves one of the biggest problems I personally had with GraphQL when I got started. Basically, as a front-end developer, you've just heard about GraphQL. You know about all of the nice benefits of it, but really to get started, you first would need a GraphQL API to really use it and to get all of the benefits. And you basically have a couple of ways there. Either you have some backend development skills and you build your own GraphQL backend, or you use a GraphQL backend as a service, but you're not really sure whether that's the way you want to go, and maybe the pricing doesn't really fit what you want to do, but you just want to get started quickly. So what GraphQL Up basically does is it condenses the simple step of defining your GraphQL schema and turning it into a GraphQL API. So this is basically what this tool does. You write your schema, for example, for Twitter, you just write type tweet, which has a text of type string and so on. You just write that down, run GraphQL Up twitter.schema, and you get a GraphQL endpoint out of the box. So we've just put that on Hacker News, and it seems it's doing fairly well.
The other thing that you mentioned to us, and I thought this was really interesting, is just who your corporate advisors are. One of them we've had on the show, and the other one I found very interesting. Do you want to just talk about that for a minute as well?
Right. So as said, we started out basically taking all of our learnings we had from working with Firebase, working with Parse, basically analyzing the entire spectrum of backend as a service. And then we sat down and thought about how has the technology and ecosystem kind of evolved, and how can we learn from their mistakes, or how things are done currently. So we are super fortunate to have one of the founders of Parse as an advisor, which is incredibly helpful for us. He has a lot of insights into the entire business, and helps us a lot regarding providing the best developer experience. So that is incredibly helpful for us. I think who you also already had on the show was Lee Byron, who is actually one of the co-inventors of GraphQL. So it's really helpful for us since we're often working with a lot of cutting-edge features around GraphQL, which are sometimes not even officially in the spec yet. And for us, it's really important how we design our system going forward, that it makes sense in the future. And this way we can sometimes bounce some ideas back and forth to make sure that it works for people. And on the other side, with all of his great insights into how GraphQL has worked for many years at Facebook scale, that also helps us to define our service.
Nice. Anything else that we should know about Graphcool, or anything that AJ or Amy, you guys want to ask? All right. Well, I will take silence as let's go do picks.
Right. So I'd actually love to add one thing, which is that together with Lee Byron, actually, we're organizing GraphQL Europe. So
nice.
Which will be the first GraphQL conference in Europe. We have Lee as a keynote speaker. We have the guys over from Polo, and basically have speakers from all around the world. And we put it in terms of timing. We just put it behind React Europe, so that actually people who are attending React Europe can also attend GraphQL Europe and vice versa. So that's going to be on Sunday, 21st, and it's going to be in Berlin, Germany.
Nice. I wish I could come.
You should.
All right. Well, let's go ahead and do picks.
Let's pause for a moment to talk about our sponsor, Taurus. Taurus is a new tool for managing and securing the secret information that allows your app to run. You know the stuff: passwords, API keys, database credentials, all the stuff that gives access to the private stuff that you don't want anybody to touch except for your application in specific ways. Taurus provides a convenient way to store all this information in the cloud, and they can't access it because it's encrypted with material derived from your password, which is never transmitted to their server. So it's secured from them, from everybody else, but accessible to you. This means only the servers, development machines, and applications you've allowed can access the information. So make secrets management headaches a thing of the past and check out Taurus today. You can find them at devchat.tv/Taurus. That's devchat.tv/TORUS.
All right, Amy. Do you have some picks for us?
I do. So my first one, programming related, is something I saw in Hacker News, I think last week, the GitHub repository, CSS Pro Tips. And I started glancing through this. And as somebody who has been doing a lot more front-end work lately and trying to get my CSS chops up in line with my JavaScript ones, I found like a lot of this stuff helpful and aligns with a lot of the stuff that I've learned in the past couple months. So that's my first pick. I would highly recommend checking that out. And then the other one is another audiobook that I'm going through right now. So I finished that Sacred Search one. And then I was also recommended to another one called For Women Only. And so since there's probably more guys listening to this, there's one for men only too. So far it is pretty good. I think it might be written by a Christian author, but there's really not a lot of, well, so far there hasn't really been any mention of like Christianity or religion or anything like that. So it's very, like a safe book if that's not your thing. And that's it for me.
All right. AJ, do you have some picks?
I'm still thinking, actually.
Okay. I'll go ahead and throw some picks out. First of all, I just want to shout out that JS Remote Conf, by the time this comes out, will be over. However, you can still get the videos if you go to jsremoteconf.com. It'll put you in the right place to get those. I'm also putting on Angular Remote Conf and React Remote Conf, so if you do either of those, feel free to submit a talk. And then finally, the last one that I'm going to pick is this audiobook that I've been listening to for a while. And I really like it. It was recommended to me by my brother, who is also into fantasy stuff. And it is called The Emperor's Blades by Brian Staveley. Now, if four-letter words bother you, it has the F word and the S word in it a few times. So if that bugs you, then, maybe you don't listen. It's not super pervasive. When it is, I can't listen to the book. And this one, it pops up every once in a while, so it's not terrible that way. But I do want to put a warning out there. If that bothers you at all, you probably don't want to listen to this book. But I'm loving it on Audible, and it's really great. And then I'm also going to pick another book, and I may have picked this on the show before, but I'm going to pick it again. It's called Deep Work by Cal Newport, and it is awesome. And I think it's a book that every programmer should read. So, I'll put links to those in the show notes as well. AJ, you said you have a pick now?
I do now. And this it's so obvious. Why I had to think at all. So, Breath of the Wild came out. And I had it pre-ordered for the past 3 years. So I've been anxiously awaiting it. And I was not disappointed. I've only played it a little bit. I have it for the Wii U and Switch, but I don't have a Switch, so I can't take it with me when I go. And if one of you has a Switch and would like to donate it to me, I would be forever grateful. I'm going to try to find one. But so what is great about Breath of the Wild is that it is, as they say, kind of a return to the original Zelda. The original Zelda, you're just plopped down and you're given like 3 lines of text. The princess needs saving, something like that. And then you go up and there's a cave, and inside the cave there's a man, and he says, it's dangerous to go alone, take this. And that's your entire introduction to the game, assuming that you do the normal thing that most people do and walk forward as your first action because your character is facing forward. So Breath of the Wild is kind of like that. It does have guidance, but it's not like, let me hold your hand and take you along the whole way quite so much as some of the other recent Zelda games have been. And it's not a rehash of Ocarina of Time. Everybody loves Ocarina of Time. It was great. Twilight Princess was a rehash of Ocarina of Time. Skyward Sword was a rehash of Ocarina of Time. In the gameplay style and such. But Breath of the Wild is a different style of gameplay in the way that Wind Waker was a different style of gameplay, and that Ocarina of Time was a different style of gameplay in its time. The music is very different because it's subtle. Breath of the Wild really carries the name there. It just, you're going about and the music sometimes appears, but it's just breathy. Anyway, if you love Zelda, I think that you will not be disappointed with Breath of the Wild. And I'll try not to give any spoilers away. I don't think I have. But it's a different style of gameplay, and I like it. I'd also recommend Kubo and the Two Strings if you haven't seen that movie, because if Zelda were to be made into a movie, I think that's what it would be like. Those are my picks.
All right. Johannes, what are your picks?
Right. I basically have one very special pick for me, which is I've jumped onto the React Native bandwagon pretty early on. And there were always like a lot of rough edges and was never really smooth to get started. And just yesterday, basically, there's a new tool released called Create React Native App. So it is what the name suggests, just like create a React app, but for React Native apps. And it is just like a really big deal to make it easier for people to write React Native apps. So I highly recommend everybody to check that out.
I get to spy on the React Native Radio podcast panel when they discuss their upcoming shows. And I know that they have either lined it up or they are very close to lining up the person who created that. So if you're into React Native and you want to know about this kind of thing, then definitely go check out React Native Radio, and that's at reactnativeradio.com. All right, Johannes, if people want to follow you on GitHub or Twitter or start one of your repos or check out Graphcool, what do they do?
They basically go to graph.cool or follow me on GitHub, which is my last name, Schickling. I think you can find it in the show notes, or on Twitter, which is basically _Schickling. And yeah, just follow me there or follow our account. And yeah.
Yep. And I'll just point out, if you're listening to this and you want to just go look it up while you're at it, it's spelled how it sounds in English, except for the sh at the beginning is SCH.
Yes, exactly.
All right. Well, thank you for coming, Johannes. This was really fun.
Yeah, thanks for having me. It was a pleasure.
All right. Well, we'll go ahead and wrap this one up, and we'll catch you all next week.
Bye.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.